Hello everyone, welcome back to AeroHub and welcome to the series of lectures in Gate Aerospace, and this is part number 1 of flight mechanics. And you can see the first question. Calculate the position of the center of pressure and aerodynamic center of an airfoil of chord length 1 meter, given that the CL, that is the coefficient of lift, and CD, that is the coefficient of drag, at an angle 6 degree is 0.4 and 0.0112 respectively, and Cm, which is nothing but the coefficient of moment about quarter chord point, is minus 0.1. Okay, so basically we have to find out the position of center of pressure and aerodynamic center of the given airfoil, and we have the value of CL, CD and Cm as well as the angle of attack. Okay, so I'll be writing the formulas. You have to just remember these formulas. Okay, so these are the standard formula we are using to find out the position of center of pressure and aerodynamic center. And you are aware about what is center of pressure and aerodynamic center, and center of pressure will be changing with respect to the angle of attack, but the aerodynamic center, that is it is a center about which it's a particular point about which the pitching moment is always a constant. That is, when you change the angle of attack, the moment acting on that particular point is always a constant. That is nothing but dCl, that is dCm by d alpha will be 0 at aerodynamic center. Okay, I repeat, the rate of change of pitching moment with respect to the angle of attack will be always 0 or a constant at aerodynamic center. Okay, so first of all we will find out the value of center of pressure, that is xCp by C, this is the formula, is equal to minus of Cm divided by Cl cos alpha plus Cd sin alpha. Okay, so I am not going to derive this expression and all, that is purely waste of your time, and for gate examination they won't be asking any derivation, so you have to directly just remember these formulas which I am using to solve the problems. Okay, so this is nothing but equation number 1, which is used to find out the position of center of pressure. Okay, in center of pressure we have your aerodynamic force acting on that. Okay, so we have the value of Cm, that is minus 0.1, and we have a minus for this also. The minus of minus 0.1 will be plus, and the value of Cl is 0.4 cos angle of attack is 6 degree plus, this is not 5, it is 6 degree cos, then sine 6 degree into CD. What is CD here? 0.0112. Okay, exactly CD sin alpha, and this is the method to find out the value of center of pressure, and I'll be getting an answer of 0.251 meter. This is the position of center of pressure. Okay, now I have to find out the position of aerodynamic center. So the aerodynamic center is very important position for an airfoil section. It's given by AC by C is equal to minus of Cm quarter point divided by Cl. Okay, so we have minus of Cm of quarter point is minus 0.1 divided by Cl. Cl is how much here? 0.4. Okay, So we'll be getting 0.25 exactly. This is the value of aerodynamic center. Okay, it is nothing but the position of aerodynamic center. Okay, so we have the two formulas. This is equation number 2, and we have certain other formulas through which we can find out the value of aerodynamic center. Okay, our next question: an airfoil has a lift and drag coefficient of as 1.02 and 0.03 respectively, and the pitching moment about the quarter point is minus 0.11 at an angle of incident of 7.5 degrees. Calculate the location of aerodynamic center and center of pressure, assuming that the pitching moment at quarter point at zero lift is minus 0.04. Okay, so they have given actually the pitching moment about aerodynamic center, that is they have given the pitching moment at quarter point at zero lift is minus 0.04. this is nothing but the pitching moment at aerodynamic center. Okay, that is minus 0.04. okay, and at an angle 7.5 degree we have a pitching moment of minus 0.11. so I'll be writing this as CM. N is nothing but the position. Okay, minus 0.11. okay, now they are asking to find out the location of aerodynamic center and center of pressure. So center of pressure we are using the same formula, XCP by C is equal to minus CM by CL cos alpha plus CD sin alpha. Okay, so if you substitute the value of CM here will be minus 0.0111 minus 0.11 divided by CL. CL is how much here? 1.02 into cos 7.5 degree plus CD is 0.03 sin 7.5. okay, so I'll be getting an answer of 0.9947. this is the value for center of pressure. This formula we used in the previous problem. Okay, now we have to find out the location of aerodynamic center. Okay, so I am introducing a new formula here. So aerodynamic center is equal to N plus CMAC minus CMN divided by CL. Equation number 2. This is the formula. It's a really easy formula. Here N is nothing but the position at which we are calculating the value of CL and CD. Okay, N is nothing but the point at which we have the data of CL, CD as well as CM. Okay, so N is nothing but the point at which we have the aerodynamic data, that is the value of CL, CD as well as CM. Okay, so in this case we have the value of N as N. Aerofoil has a about quarter point. Okay, about the quarter chord point. So the N will be 0.25 and CMAC is we have minus 0.04 and CMN at an angle. Okay, this CMN is nothing but the coefficient of pitching coefficient at an angle 7.5 degrees. Okay, then we have the CL is 1.02. okay, you substitute the value, that is AC is equal to 0.25 plus minus 0.04 minus 0.11 divided by CL is 1.02. Okay, so I will be getting an answer, and the answer is 0.32. This is the answer, and this is the really an easy way to find out the value of aerodynamic center, and this will be an important question for the gate examination. Okay, please be note this formula, and n is nothing but the point at which we have the aerodynamic data. Okay, so we'll be solving more problems on flight mechanics in the next lecture. Thank you for listening. Take care.